In this video, we're going to be solving quadratic equations, and we're going to start our discussion by introducing a basic idea of the square root property. But first, the general quadratic equation looks like this: ax squared plus bx plus c, and a is not 0. We're going to get there, but first, we're going to talk about an important principle that guides all the work that we're going to do. And this is the square root principle. Now, before I write the principle down, notice that if I put negative 2 squared, the answer is 4. And then if I put 2 squared, the answer is still 4. So, replacing negative 2 and 2 with x squared is 4 has two solutions. X is equal to negative 2 or x is equal to 2. And these numbers come from both square roots of 4, the positive and the negative. So we summarize this fact by stating the square root property. The square root property says if x squared is equal to c, a number, then the two solutions are x equals negative square root of c, or x equals the positive square root of c, or just square root of c. Sometimes this or statement can be written as x is equal to plus or minus square root of c. So let's take a look at some examples. We're going to solve these examples using the square root property. So in number 1, let's take a look at the equation x squared is equal to 100. So using the square root property, we say that x is equal to negative square root of 100, or x is equal to positive square root of 100. So x is equal to negative 10, or x is equal to positive 10. And those two numbers live in my solution set, negative 10 and 10 in this set. On the number line, we can graph the solution set. Here's negative 10, here's 0, equal distance to 10, and we're going to mark 10 and negative 10. The solutions of quadratic equations will always have this symmetry property. Not always about 0, but always be symmetric about some number. Now, in this next example, we're going to put x squared plus 5 is equal to 14. Now, in order to use the square root property, we want the left-hand side to be a perfect square. So subtract 5 from both sides to get x squared equals 9. This now has the same structure as the square root property. So the left side is a perfect square and the right side is a number. We'll use the shorthand for this. The shorthand way of writing this is x equals plus or minus the square root of 9. And simplifying this, we have x is equal to plus or minus 3. So the two numbers that live in my solution set are negative 3 and positive 3. And again, on the number line, we can mark negative 3, 0, and equal distance to 3. So the two solutions are negative 3 and 3. Let's take a look at a couple of more examples. The next equation will be 2x squared plus 7 equals 57. So here we do have a perfect square on the left, but that's not the only thing. We have other quantities. We have a multiplier, we have an addend. So first get rid of the 7 by subtracting both sides by 7. That gives 2x squared equals 50. And then divide by 2 to get x squared equals 25. The square root property puts x as plus or minus the square root of 25, or x as plus or minus 5. And those are the two numbers in the solution set, -5 and +5. So my number line will have those two numbers marked and shaded in, -5, 0, 5. Okay? We want to see a lot of examples to get comfortable with all the possible types of questions you can answer with this square root principle. So let's take one more. Y plus 3, the quantity squared, is equal to 100. Now this equation looks a little bit different than the other one, but it still has the property we want. It still has a perfect square on the left side. So we can remove the perfect square as long as we replace the right side with plus or minus the square root of the number 100. So let's simplify that. Y plus 3 is equal to plus or minus 10. So here we really have two equations. The two equations are y plus 3 is equal to -10, or y plus 3 is equal to +10. Subtracting 3 from here gives y equals -13, or y is equal to, subtract 3 from here, you get 7. So the two numbers we're going to mark on, or let's start with the solution set. The two numbers in the solution set are -13 and +7. Now on the number line, we can mark the two numbers -13 and 7. When we talked about symmetry a minute ago, the symmetry is not from 0, but what is right between -13 and 3? So let's mark these. These are the solutions, but it's useful to think about the middle point, -3. And that's going to be important when we graph.